Okay, in this video, I'll talk about the solution for assignment 3. And similar to last time, we have two problems. So let's begin. So the first one, an electron that has instantaneous velocity of like this is moving through the uniform magnetic field B equals this. So find the force on the electron due to the magnetic field. So for this problem, I just like to let you learn about how to really calculate the cross product. Actually, you only use the simple expression F equals Q V cross B in the Cartesian. So we know the expression of V and B in the Cartesian coordinate 底卡坐标的 So actually calculating the cross product is not difficult, but I think you should use some effort to learn about it, because although you may not use the EM theory much more later, but actually in the mechanics you should have known the torque should be the R cross the force. So actually this is the torque. Actually cross product is an important operation that you need to know. So in the slides, mainly you know that if we have a vector A and vector B, so the cross product you can use the right hand rule, so that A cross B should point to this direction, and actually A cross B, the amplitude of A cross B would be the amplitude of A times the amplitude of B times sine theta, which is the angle between these two vectors. But this time we know that the two vectors in the Cartesian coordinate. So something we need to know is that there are some fundamental operation about the unit vector. So actually we have 9 combination. Actually we may have I cross I cross sorry, I should leave some blank in between. We may have I cross J. We may have I cross K. I, J, K are the unit vector in X, Y, Z direction. And actually we have J cross I, J cross J, J cross K, and K cross I, K cross J, and K cross K. So actually in the diagonal there are the simplest case which are 0, which means if a vector cross product with itself, it will be a zero vector, because it is quite simple. The theta between them should be 0, so sine 0 degree is 0, so a vector cross product with itself would be a 0 vector. So the next one is I cross j. I cross j will be k vector, and j cross k will be I, and k cross I will be j. And I use another color, green color. So I cross k will be minus j. J cross I will be minus k. K cross j will be minus I. So it may be difficult to remember, but actually you can draw something like this. Okay, we can write I, J, K like this. I, J, K like this. If we rotate counterclockwise, clockwise, if we rotate clockwise, which means that if we have I cross J, something like this, I cross J, which is this one, we have K. If we have J cross K, which is this one, we will have I. And if we have K cross I is this one, we will have J. So if we rotate clockwise, then we will have a positive answer. However, if we have counterclockwise, I, J, and K, if we rotate counterclockwise, for example, we have I cross K. I cross K is this one. So we have negative J. So we have a negative 1 here. Likewise, if we have K cross J is this one. K cross J is this one. So we should have minus I like this. If we have J cross I is this one. So we should have minus K, something like this. So actually, for the diagonal cases, we have 0 vector, but so we have 3 0 vector as the answer, and we have 3 positive 1, which is this case, and actually we should have another 3 cases, which is well, this one, and this one, which is this case. So actually, if we can handle this equation, then we can calculate the cross product easily. And note that cross product is something not commutable, which means that I cross J is equals to minus J cross I. We cannot simply exchange the order, because when we exchange the order, then we should have another minus sign before it, which means that if we exchange the order of the cross product, then we should have an additional minus 1 multiplied by it. And for sure, you shouldn't ignore this cross sign, because it's not the scalar case, or for scalar case, you can just drop it. But for the vector, you may have dot product, cross product. So you should write it adequately. So let's go back to here after we know the operation for the cross product of the unit vector in the Cartesian coordinate. So we can substitute all the stuff into here. So actually we have Q, let's say Vxi plus Vy j. So for now, 2.0 times 10 to 6 is Vx, 3.0 times 10 to 6 is Vy, and cross B is this. So we have Bx, which is 0.03 is Bxi minus By or plus By, well, maybe I should write it as plus By equals to minus 0.15 Tesla. J, something like this. So actually we can just multiply it out. So first we have this term multiplied by this term. So we have Vx Bx I cross I. So this one should be a zero vector. And the next case, Vx I cross this one. So we have Vx By I cross j. And the next one, we have this term multiplied by this term. So we have Vy Bx j cross I. And finally, we have this term multiplied by this term. So we have Vy By j cross j, which is a zero vector. So actually, this one is a zero vector. This one is a zero vector. And I cross j, this one is k. I cross j is k. So this one is minus k. So finally, we should have q times Vx by minus Vy Bx times k vector. And then we substitute all the value into here. So for Q is an electron, so the charge should be minus 1.6 times 10 to minus 19. And then Vx is 2 times 10 to 6, and By is minus 0.150, and then we minus Vy is 3.0 times 10 to 6 multiplied by Bx is 0.030. Okay, should be like this. So so finally we can just use a calculator to know that the answer will be 6.2 times 10 to minus 14 Newton k times k vector. So this is the answer for question 1. So for question 2, which question 2. Okay, maybe we just move it a little bit far away. Okay, so for question 2, so the problem is like this. So a wire ring of radius A equals 1.8 centimeter. So and this is perpendicular to the general direction of a radially symmetric diverging magnetic field. So actually, this magnetic field is not uniform. It's just like pointing outside. So if you can imagine, you can just extraordinarily order the B field, then it will join at a point quite far away, because this is 20 degree. And so actually move on, the magnetic field at the ring is everywhere of the same magnitude. B equals 3.4 millitesla. And the direction of the ring everywhere makes an angle 20 degree with the normal plane of the ring. The three slit y have no effect, so we just ignore this part. Find the magnitude of the force field exerted on the ring if the ring carry a current I equals 4.6 milliampere. So actually it's just like an apple pie, so let's consider like this. Maybe we can draw a larger figure here. So actually maybe we consider these points, we call this part ds, and the B field is pointing like this. So it should have two components. One is perpendicular to this ring, and one is actually on this plane. So so here we should know in this problem is df should equals to I cross I times B cross ds or dl, depends. So it's an other form of the Lorentz force. For the Lorentz force, it is Q times V cross B, but here in a wire we have a current. So actually for current, it's just like some charges moving. So in this case, we have the form like this. We have the form like this. So in this case, B points to this direction. Points to this direction. Oh. B points to this direction, and actually ds, okay, ds something like this. This is I. So we should consider ds should be in this direction. ds should be in this direction. Should be in this direction. Should be something like clockwise. But this is a 3D graph, so it's not easy to be observed. So for the magnetic field, it can separate into two components. One is the vertical component, and another one is the horizontal component. Maybe I should use another expression. So in this case, if we just use the right-hand rule, the cross product, so this is so B is the first vector, and ds is the second vector. In this case, B cross ds should point to that direction. This is df. This is df, and you can consider in the opposite side, B should be point to this direction. This is maybe I use another color. This is ds. So B cross ds should point to this direction. Hope you can understand this. ds prime, df prime. So in this case, we can consider that df can be separated into two components. One is the horizontal one, and another is the vertical one. df, this is horizontal one. This is the vertical one, and df prime should be something like this. This is the df vertical one, and this is the df horizontal one. So you can clearly see that this one and this one, the horizontal one, cancel each other, and the vertical one points to the same direction. So that all the little force will sum up with So finally, the total force will be integrating dfv, and actually dfv will be I, also B dot ds psi theta. So let's check. According to so for dv should come from should come from B cross B cross ds, and it should come from this component. As long as we have B points to this direction, and then it cross product with ds, it will point to the bottom direction. So theta should equals to 20 degree. Theta should equal to 20 degree. And in this case, I is a constant, sine theta is a constant, and also B is also a constant. So we just fractal of them out, and we have an integration like this. And so for this integration, it is nothing but 2 pi a. So their answer is something like this. We can substitute all the stuff in. I is 4.6 times 10 to minus 3. 4.6 times 10 to minus 3. B is 3.4 times 10 to minus 3. Sine 20 degree. And 2 pi times A is 0.018, 1.8 centimeter. 1.8 centimeter. So finally, the answer will be 6.0 times 10 to minus 7 Newton. And force of the magnitude exert. And actually, this force should be pointing downward, but although the is not in the question, but actually this force should point to the downward. Okay, so that's all the answer about the assignment 3. And if you have any question, please let me know, and I'll try to answer your question, and I'll see you next time.